Welcome to Click Academic. This is lesson number 2 on the series of logic and set theory. We will be discussing on logic as we have started earlier in our first lesson where we talked about connectives. So today we are going to talk about the first connectives, which we have said. The first one, which is what? Conjunction. And we see that the symbol of this conjunction is like this, right? And in a statement, it almost occurs in the form of what? And. Now, maybe you'll be given, let's say, a statement. Let's say Omar is a student and John is a what? Is a governor. Now, this is a statement. So we can say, okay, let P be equal to Omar is a what? Student. And then let Q be equal to what? John is a governor. Then to represent this symbolically, we have what? We also keep P. Now if you look at this, this is our connectives. And we use as what? In the form of this. And what? Q. So now this statement, Omar is a student and Jen is a governor, it may represent symbolically using logic in this form. So now, in this time of conjunction, it said that a statement is said to be true, that the conjunction of this is true if both are true. Meaning, if this P is true and Q is true, therefore the statement is what? The compound statement is true. But if, let's say, P is true and Q is false, then now the statement is what? Is false. So okay, the last condition said if P is true and Q is false, therefore is false. Meaning true is true, false is false, and false is false. Meaning in conjunction, using this can be true if both are true. That is what the conjunction is all about. Now let's use truth table to see how it works. Let's say we have P, Q, okay. Let's say we have this. We have P and Q. That is this. Then let's take the commutative aspect of it, which is this. Now let's say true, false, false, true, false, true, false. That's how we do it. Then now remember in the conjunction say that it's true if both are true. Now true is what? Is true. True false is false. False true is false. False false is false. That's what the conjunction is saying. And also okay, Q and P. Now we are going to consider this. True is true. False, you see, is false. This and this is false. False is false. Now if you look at it, you see that this column and this column look alike. They're the same. So you can now say, okay, therefore, P, O, Q is logically equivalent to Q, O, or Q and P. This is logically equivalent because we don't have equal to a logic. It's just logically equivalent. And this is called what? Commutative. Meaning, this conjunction is what? Is commutative. Right? So, now this is about conjunction. Then now the next thing we're going to talk about is what you call disjunction. Now to talk about disjunction, that is number 2. Disjunction, and we say that this is the symbol of disjunction, and is represented in the sentence in the form of O. Remember that constant that we have said. Okay, let's say we have Umar is a student as the previous one. O, Jan is a governor. Now this is the statement. So for us to represent this symbolically using that, you remember here we let it to be P and the other one let it to be Q, right? So using O statement, we now say symbolically it will be P. Now this is O statement, O, Q. Now this is symbolically. In this aspect of conjunction, you see that this statement is true if at least there's one that has a true value. Now let's take it as that this way. Let's say okay, P, when P is true, O, Q is true. What will be the answer? Then it will be true. Then let's take it, okay, when the next condition, let's say when P is true, O, Q is false. What will be the answer? It will be false, true. Why? Because at least one value is true. The other way around is when P is false and O, Q is true. You see at least true value exists, meaning it's true. Then the last value is when P is false, O, Q is false, therefore here it will be false. Meaning in the condition or in the case of disjunction, it's false if both are false. That is in the case of what? Called disjunction. Now let's use truth table to see how it works. Let's say we have P, Q, you have P, O, Q. Let's say we have Q, O, P. This is what? True, true, false, false. This is true, false, true, false. Now, remember we say that if both like true, true, if both are true is what? Is true. If at least there is a true value, what's the truth? True. At least true value, true. But this one are what? False, false, therefore is false. Right? Now, the next aspect is what? True, true. Key true, this is true, meaning it's true. At least true occurs. True, false, false, which is false, right? So here with this we can conclude and say, okay, therefore P, O, Q are logically equivalent to Q, O, P, and is also called commutative. Because why is it commutative? Because we change the position of what? The position of P and Q. We only change the position. Here is P, here is Q. You understand? So I think this is the end of our lesson. Thank you very much. We'll meet in the next class.